Our next lesson, we're looking at exponent rules. This should be a review from Algebra 2 as well. First of all, the definition of exponential form is simply repeated multiplication. So that power tells you how many times you're multiplying the base by itself. I'm going to let you look over these properties of exponents on your own. I'll go through most, if not all of them in the video. If you have questions on any of them, of course, always ask me in class. We're going to simplify several expressions with exponents. Our first one, we are multiplying and we have negative exponents. You'll see off to the right that I have some steps listed out for you on this video. Steps 1 and 2 don't necessarily need to be done in that order. A lot of students find it easier to work with positive exponents, so if you get rid of those negative exponents first, it may make your job of simplifying easier. So I'm going to start by simplifying those negative exponents first. We'll leave our first expression alone. That second expression, just the piece with the negative power, will move to the denominator. The 4a both have positive exponents, so they stay where they are. We'll multiply straight across. 4 times 3 gives us 12. A times a is a squared. And then when we have b to the fourth divided by b cubed, that leaves us with b to the first power, or just b. Our next one is a pretty straightforward power of a power rule. Remember, when you're taking a coefficient to a power, you do not multiply them. 2 cubed is 2 times 2 times 2, or 8. X cubed. And then y squared cubed, we do multiply those powers. We get y to the 6th. Part C, anything to the 0 power is 1, so we're left with 3a. This entire expression equals 1. When we multiply 3a by 1, we get 3a. Part D, we have another negative exponent. I'll take care of that first, moving just the x cubed to the denominator, making that negative exponent positive, and then we'll distribute that square. 5 squared is 25. X cubed squared is x to the 6th, and y squared is y squared. Our last simplifying one, again, moving just those pieces with a negative exponent. I'm going to move that b to the 4th to the denominator. The 4 stays in the denominator. A to the negative 2 moves to the numerator, and b stays in the denominator. If you couldn't follow that, this b to the negative 4 went to the denominator. This a to the negative 2 moved to the numerator, and all of the other pieces of this expression stayed where they were. Starting to simplify, I'm going to take 12 divided by 4. Those are coefficients, not exponents, so I divide instead of subtracting like we do with powers. A times a squared is a cubed. And in the denominator, we have b to the 4th times b, which is b to the 5th. In this next example, I am going to make a mistake, a common mistake that I see a lot of students make when they work with exponents. Your job is to find and fix the mistake that I make. We will start class talking about this question. Starting off, I'm going to distribute that negative 2 power. We have 3 to the negative 2 power. Power of a power rule means I multiply my exponents, so negative 3 times negative 2 is a positive 6, and that negative 2 gets distributed on the y in the denominator as well. In the numerator, 3 to the negative 2 power is negative 9. We have x to the 6th, and that y to the negative 2 from the denominator moves to the numerator, and the exponent becomes positive. Again, as a reminder, there is an error in this problem. Your job is to find and fix the mistake that I just made.